Hold on. No, you guys can't see it yet. Well, all right, from a distance. But we're going to get into it. In this video, I'll take you through step by step exactly how I created this very special machine here. Now, this is a heavily modified two-tree sapphire that was the original sapphire, not the Pro, not the extended, any of those. They stopped making this, and that's a dang tragedy because you see these rods? They go all the way through the floor, and the motion control steppers are underneath the floor here. So what this allows me to do is every single component that's a part of the motion system, meaning the bearings that constrain the motion, or that's a part of the movement system, like the stepper motors, it's all made out of metal with the exception of the belts. And these belts here have Dyneema Spectra. I think that's what the fiber is in the core, and I'm probably going to get some stainless steel core belts in there as well. So even though they are rubber belts, I think that we'll get very little stretch or very little temperature effect happening on the belts. Other than that, you have some insulation on the wires, you have some sort of like end caps to the bearing blocks, but it's all metal. So it should really be robust enough to withstand the, 75 degrees, 100 degrees Celsius temperatures that I will have inside of the enclosure. So while this printer is not inside of the enclosure yet, I've made some great strides, including an all-metal hot end with an all-metal extruder attached to it. Stay tuned. I'll show you guys how I got here. This is what the BQ H2 extruder looks like fully assembled. And this one I've partially disassembled in order to pull the hot end off of it. Now, a couple of notes here. First of all, this throat is not an all-metal heat break. So you can see a PTFE liner there, and that means that it's not good for high temperature plastics. It's well known that PTFE at temperatures above 100 or 265 degrees Celsius starts to decompose and off-gas very, very poisonous chemicals, nerve agents, stuff that will paralyze you, really, really nasty stuff. So definitely do not heat this up above 265 degrees. Now, I've been calling this all metal construction, meaning the whole thing, meaning there's no plastic anywhere in this assembly where it matters. You got some plastic silicone here for the boot. You have a little bit of plastic here on the PCB just for the connector for the electronics. But other than that, everything else is made out of metal. So unfortunately, we have this terminology of all metal hot ends in 3D printing. And that's a reference to a time long ago, thankfully, when the hot end was encased with PEEK high temperature plastic. It's ridiculous. Whoever thought to put plastic on a hot end, needs to be fired. And thankfully, we no longer make those. But at a time, the narrative needed to shift away to get us off of and away from those ridiculous plastic nozzle designs or hot end designs. And that's why we call things all metal. So we should stop calling things all metal, because then it gets confusing when I'm talking about this thing being made of all metal. Okay, so now that we've put that one to bed, I am going to make this an all metal hot end because I've got a Slice Engineering Copperhead throat here, and that has no PTFE liner. That is stainless steel and the skinny part there in the gap, and then this is zinc coated copper, some kind of electroplating over the copper. So that's going to replace the throat here that came out of the H2 extruder. Now, this H2 extruder hot end is, I think, a Chinese clone of another Chinese design, or maybe it's a genuine, from that factory. Who knows? China is one giant corporation, and they've got teams, and they borrow from each other, and they trade over employees all the time, and it's not really companies. It functions more like teams in an environment, a corporate environment in the United States, than separate companies. They don't have the same rules over there for companies. So anyway, this hot end has a smooth portion here that slides into that receiving hole on the portion of the extruder assembly here. And if you measure this, it comes out to 6 millimeters. Now I've got the Mark 10 Copperhead throat heat break, portion here, and that comes out to 7 millimeters. So I'm a millimeter too large. And the easy solution here would be to drill out this hole 1 millimeter. So if I was just 1 millimeter larger with that hole, but the problem is we've got these very thin walls that are only 1 millimeter thick right now. So we would be talking 0.5 millimeter wall thickness on either side of that hole. I just don't trust that to be enough strength. So what are my options? Well, Slice Engineering does make a smaller version of the Copperhead heat break, but it's much shorter. So it should be the correct diameter here, but it won't fully seat into the hole. And I don't like that. So the only option I have then is to modify this part. I've got a 1/4 inch SAE nut. So that starts to thread onto the metric threads here, but then it jams, and that's exactly what I want. So I can stick this into my drill press. Well, I've got this in the chuck with the minimal amount of run out that I'm capable of achieving on this drill press. So what I'm going to do now is take this sandpaper cylinder on my Dremel tool. As the drill press is sprinting, I'm just going to go like that until it measures the correct diameter with the calipers. I'm actually finding it easier to use this file. Now I'm not pressing too hard because it's just that thin piece of stainless steel throat there, the heat break, that's holding this part. So I can't push very hard, but by kiss cutting it, I'm able to get this nice pile of copper dust down there, and it's coming along nicely. All right, well that now slides into the hole on the extruder part here. So all we have to do now is cut this to length. So I'm going to use this hacksaw blade right here on the drill press to make that happen. Well, that fits in there beautifully, and it seems like it's going to work. There is one big red flag, however. The wall thickness varies substantially, so I did not get this thing centered. We're at like 1.2 millimeters here on the side wall, and then on the opposite side we're at like 0.79 millimeters. So what is that? Oh, 0.75. So 0.5 millimeter variance between the sides there. That's pretty substantial. All right, bringing you guys up to speed here. I removed the front bar. You can see it was kind of a pain in the butt. It just got in the way. Now with it removed, very nice access to the print or the nozzle if you need to, load some filament or something. There's the little lever right there for loading filament. Here is the Bowden tube. I'm gonna cut that down at some point. So yeah, the BQ H2 extruder is nicely mounted in place. We can see under there we've got the Slice Engineering Copperhead nicely mounted, ready to receive the thermistor and the heater element. So yeah, this is mounted pretty securely. If I really grab it, I can get a little shake out of it, but everything is good. This looks pretty ugly. I know what you guys are thinking. Those holes, I just sort of freehand drilled them. I didn't measure anything. I just kind of went to town on this. This is called Drillium. It's a thing from antiquity in the bike world when they used to lighten up bike components. I just wanted to remove some of the weight. I added a 90-degree metal bracket here in order to get that mounted. So just to cut 4 bolts and a 90-degree bracket. So probably all things told, it's about the same amount of weight as it was before now that I drilled those holes. Not light, could be lighter, but I'm pretty happy with this tiny little direct drive. Pretty substantially lighter weight than anything else out there on the market, which is made out of 100% metal. And now this is an all metal hot end with the Slice Engineering product there. So what's next? I've got to mount this 110 volt AC heater pad underneath the bed there, and I've got to run it through an SSR solid state relay so that I can run that with mains voltage. That will heat up quite nicely. And I also need to make a custom mount for the filament holder. I want to put it right here like this, floating in space right there. That's going to be the best location for it. Yeah, and the reason for this location will become pretty apparent as the project progresses. And the final task for me to do right now is to clean up all this wiring. I'm going to drill a hole right here and pass the wiring up through that hole. That way everything will be contained within the envelope of the cube shape of the printer. All right, let's get back to work. The wiring job is mostly done. There are going to be a few things that I will plug in the future, but for now, this is fully functional. Now, what did I change for this build? I added these 2 solid state relays as well as this emergency stop button here. These 2 relays are very power hungry because they're running 2 heater elements. So this one right here is controlling that silicone mat that bed heater there, and this one's going to be controlling the chamber heater. And so that is just a lot of juice going to those two heater elements, and I thought it was prudent to add this extra 120 volt outlet to the printer. One thing that's interesting to note is I've got the safety ground wire here going to the frame. So from this plug on this side, which is going into the wall, so 110 volts AC, yeah, that goes to the frame. So I was touching the frame here with this palm, and then I touched that terminal right there, and I got a nice shock. So what would it be? A 55 volt, 30 hertz shock to my fingers. Was not comfortable, I'll tell you what. So it would be nice if the solid state relays had some sort of a cover on them, similar to this. See these little flip up covers? I like that. But you know, this is going to be under the printer and hopefully nobody will touch that. Maybe I'll 3D print something. I don't know, but whatever. So the majority of the printer operations happen through the stock control power, and it even can heat up the bed because I kept the old bed heater module. So I effectively have two bed heaters going on here. There's the PCB bed heater that came, you know, as part of the bed, and then there's the silicone mat that I've added. So that bed will heat up nice and quickly with two heaters on it, and I don't need to have this side plugged in. This is just for the extreme measures of the chamber heater as well as really nice bed heating. A really cool feature about this printer is the ability to turn it off from the firmware there, from the web interface. You can see the lights just went out and the fan is no longer making noise. But that's not all that useful, you guys. It's kind of a nice to have. Maybe it makes you feel good about the safety of your printer, but really not necessary. And it requires this special power module to make something like that happen. All right, it's time to get the firmware set up for these changes. The biggest difference here is going to be the lack of a BL Touch. Now I've kept the wires, these two wires here, the black and the white wire, going to the sensor, as well as these three servo control wires. I might use these for an LED or something like that. I'll figure it out. They still are routed all the way up to the hot end. But I removed the BL Touch, and let's talk about that. All right, you guys know that I love BL Touch sensors. I put them on almost all of my printers, and you know, when these things were newer, there was all kinds of, you know, trolling, trying to spread FUD, I guess. You know, trying to just, you know, take away the market share that BL Touch was surely going to have, just because they have such a winner of a product here. And I've never experienced any of the problems that everybody else was complaining about. So, you know, they're just a flawless sensor for me. This is the genuine article. I did try to get some clones to work, and I kind of hacked them together and got them working eventually, but it was a pain in the butt. And BL Touch sensors, they work the way that the instructions tell you they're going to work every time. But I do have one major problem with them, and that is the fact that they will not work above 50 degrees. So I had a BL Touch sensor on my original heated chamber build of a 3D printer, and as soon as that chamber got to 50 degrees Celsius inside, the BL Touch starts flashing a red warning light and it stops functioning. So the smart functionality here means that it's got a temperature probe built onto the PCB, and it knows when it gets to 50 degrees and it stops working. And why would they do that? Because the inductive probe here is sensitive to changes in the temperature, and it will give you different fluctuating readings based on how hot or how cold it is. So yeah, that's basically the same technology in a Pindaprobe, like, you know, the Prusa Pindaprobe, but in this case, they've attached that inductive sensor to a probe that deploys and retracts. So I do love this direct measurement of the print surface. That's the winner. I don't love the probe. I wish they would use some sort of an optical probe or something that wasn't temperature dependent. So there's absolutely room for somebody to come in here and make a better deployable probe sensor. There is room for that, and I wish that somebody would get on that and make it happen, because BL Touch has been around for a number of years. It's time we saw an upgraded functionality, not inductive sensor based. So the bed probing strategy that I'm going to use is basically a copy of this sensor from my FLSun Q5 Delta printer. I actually think this is quite functional. It's just a robust clicky switch, and it magnetically attaches to a little boss that's attached to the hot end. So this is a removable thing. You plug it in, You set it up so it's directly beneath the nozzle, you run your bed leveling algorithm, you take it off, and you start your print. Now, you don't need to run a bed leveling algorithm every time you print, especially if you're gentle pulling things off or if you have a flexible detachable bed surface like this. So what's going to happen here is I'm going to run this every 10 prints or so, and in between every print, I'm going to be doing an auto home, which homes to the bottom of the printer down here on this switch. So that's what it is. That's the homing Z. So it homes at the bottom and moves back up to the top. And if need be, I map the bed with this. A few weeks back, I actually asked you guys on the community tab of my channel where I could find that switch. And some very helpful folks gave me a link to these switches. They're not easy to find. But yeah, I do have to solder them onto a PCB because there's no screw boss or through hole to mount these to anything. So it's going to be a little bit of a challenge duplicating this, but I'm up for it and we'll get that done. But I don't need to map the bed just yet. I can get it printing before I've made the bed probe. So let's get into the web interface and get this printer set up. This video is not a tutorial video, so I'm just going to gloss over this really quickly. But for anybody uninitiated with Duet control boards and RepRap firmware, what you're looking at here is the interface. It's through a web browser, so I absolutely love the simplicity. Just open up a web browser and you're controlling your printer. You can do everything from homing it to setting the temperature of the nozzle and the bed. Here's where you put your jobs. You can upload them. As soon as you slice it with your slicer, you just click this button and wirelessly upload the file to your printer, and then you can watch it printing. This will give you the layer lines. It's a chart of how much time it took each layer to print, and then it gives you an estimate of when the print is going to be finished based on filament usage, file progress, or layer times. Those are all they differ a little bit. And the fourth one that pops up, if your slicer has provided the information, is an estimate of the time based on what the slicer thinks is gonna take. So awesome way to really have a pretty good idea when your prints are gonna finish. And I absolutely love RepRap firmware for this interface, but you can get this interface with your Marlin or Klipper builds as well if you use Octoprint. I prefer this interface. I think it's cleaner. I don't like the graphics on Octoprint. I think there are skins, but they're not. The ones that I've seen are meh. So yeah, I prefer it for that reason. But more than anything else, this is what makes RepRap firmware truly superior in tandem with the Duet control boards, and that is the ability to control the firmware. You can upload the latest version of the firmware right here through the web interface, and you can change the configuration file. You can change the variables. If you just want to tweak a variable a little bit, it's super easy. You open up config G, you change a variable. By the way, all these variables are G-code commands. You just go here to the Duet 3D G-code dictionary, and you scroll down. You can do a search for English words. Like you want to say like turn your printer nozzle on, nozzle heater temperature or something like that. You'll find those there and you'll be able to read this and it'll tell you how to change this up. But there's also an online configuration assistant where none of this, you don't need to do any of the code. I mean, I prefer to kind of start with the configuration to get a rough build and then I jump into the actual coding myself. It's a more powerful way to do things. But yeah, I absolutely love this. And you cannot do this with Marlin or Klipper. You have to connect a USB cable to the control board. And, every time like with Marlin, you have to compile the code in your Arduino IDE. You change a little bit of the variable, you recompile the code, then you upload it, then you got to read. It's so much more time consuming. And, being time crunched as I am, I've got fewer and fewer hours every year, right? And I like to not waste my time. And also on that front, buying cheap Chinese electronics, I end up wasting weeks of my life trying to get those things to work. And of course, there's going to be comments going, oh, they're so easy, trying to make me look like I'm some sort of an idiot. But hey, if you're watching my videos, chances are I've done some work that you haven't done. So maybe I'm a little knowledgeable in some realm that you could be better at than me. Hey, you guys could be more skillful in the end, but trust me, you're going to waste a lot of time figuring out those Chinese electronics. They're not worth your time. Better just to go with the best, that being Duet control boards with RepRap firmware. So, and I've said, the final critique that people want to offer is how do you control your printer at the printer? And the answer is you use a tablet or your phone. You guys, I can just pull my phone out of my pocket, open up this web page. Like I said, it's just a web page in a web browser, and I can be right there, modifying my printer if I need to be standing at it. But for most of the work that I do, I'll just turn on the nozzle temperature here. I'll walk over and grab a roll of filament. I'll go over to the printer, stick the filament into the extruder, feed it through by hand until I've flushed out the old color or old filament type, whatever it is. I'm ready to print. I walk back here to the printer. I upload my G-code file, to the jobs menu here, and then I start printing. So I hardly need to be at the printer anyway. So really a screen is not needed. I absolutely never use them. So yeah, there's that. Anyway, for this specific printer, the changes that I needed to make were minimal. Mostly I just needed to kind of cut out some of the functionality that I had built in previously. The BL Touch, for instance. I'm no longer going to be running a BL Touch for reasons that we already discussed. And I think I changed the acceleration and the jerk. Acceleration, or jerk, is the acceleration of the acceleration. So it's like an order of magnitude kind of a thing. And you can have the third order there where it's the acceleration of the acceleration of the acceleration, but diminishing returns, not worth it. We just use acceleration and jerk with 3D printing. Those are good variables to change when you add extra weight to the moving mass there. So before, this was a Bowden tube setup, so I've added extra weight, had to slow down acceleration and jerk just to get kind of cleaner prints. Had to change the steps per millimeter for the BQ-H2 extruder. A few other things. I disabled pressure advance. I don't need that. Pressure advance is for Bowden tubes. It's a patch. So I've fixed it in hardware now with the direct drive, and so that's not needed. I did also add the functionality for the emergency pause button. Not technically an emergency stop, but that is one thing that I like to be able to do. That's the one task that I needed a control board to do, and that's to quickly pause the printer if I see a problem coming in. I can maybe snip off some sort of a goober on the print or something else is going wrong, and that was the one thing. Well, with that button there, yeah, it works great. So I've added that to almost all of my printers. You guys have seen previous videos where I talked all about that. So yeah, those changes have been made. The printer is working. Let's do a test print. But before I can start the test print, I need to manually level the bed because I've removed the BL Touch probe. Now, I did notice before with the BL Touch installed and being able to run the auto tramming or bed leveling algorithm that I hardly ever needed to actually map the bed. This bed is pretty stable. It's a smaller size and it doesn't move in the y-axis. It only moves in the z-axis very slowly. So as long as I'm not too rough when I take the detachable spring steel, print surface here, when I take that off, if I'm pretty gentle, then everything pretty much stays where it's set and I don't need to level the bed very often. So I think I'm going to be just fine for the time being manually leveling this bed. And in order to manually level, I need to first get this bed up to temperature. For this ABS filament, that means 110 degrees. And I want to show you guys just how quickly I can make this happen. I'm going to press go here and you can see 21, 22, 23, 24, basically a little bit more than 1 degree per second. All right, 110 degrees has been reached. Oh, it's going to say fault. Let's just clear that fault. It's going to count down 4, 3, 2, 1, 0. Now, I do have to say, RepRap firmware does give me faults from time to time that I usually just clear. The firmware is set to be a little touchy. It gives me faults when I don't think it should, but hey, better to get false reports of heater faults than to have your printer spontaneously catch on fire. Okay guys, this is me from the future, and I figured out that fault was being caused by this M143 command here in the config.g file, and I had it set to 110 degrees. So as soon as the temperature went above 110, it tripped the fault. Now I can change this to 115 and just click the save button up here, which is what I'll do, and then reset the board, and it's just that easy. But for the rest of this video, I still have the maximum, the heat limit for the heater on the bed set to 110 degrees. Now I do have this bit of insulation, and this is something you can purchase on eBay. It's got a nice bit of stickiness to the bottom. It's covered with this paper and this foil backing there. So that is underside under bed insulation, but I don't know if I want to put this on my bed here because I'm going to be printing in a chamber, so I kind of want the bed to be radiating heat and helping keep the chamber warm. And now it's time to level the bed now that the bed is up to temperature. So I've made a macro folder here called manual bed leveling, and that's basically just going to it's going to take the nozzle to the 3 bed leveling points. But before I do that, I want to home all. Okay, and now let's go to back point. Okay, so it's hovering right over the adjustment screw there, and I can use the move Z here buttons to move the Z where I want it. So first we'll go Z -5, and you can see right there, it's telling me my Z is at 0, 0. So that should have a good little bit of friction with my paper here. And that's exactly what I'm getting. Perfect. So it's still level from the last time. All right, so my nozzle is heating. It's going to get to 250 degrees. Then I'll manually flush out any old filament left in there and start the print. All right, it's up to temperature. Move the filament runout switch out of the way. That is nicely primed. Pull the excess filament off, and we'll just start the print here. So you see how it just gently creeps along, friction-free? I mean, I can set it spinning myself with just a little bit of a impetus there, but it's the perfect amount. It really works just fantastically in a real-life situation. Oh, look, there we got a little bit of an unwinding, and that's just because of this spiral. All right, the print is finished. The nozzle temperature has dropped below 50 degrees, and the printer has turned itself off. You can see there's no lights, and the power light's not on. But best of all, I've retracted automatically 10 millimeters of filament, which means that I can easily unload the nozzle there. I don't have this welded inside of the heat chamber down there, the hot molten, filament chamber, and I can remove the filament spool from the printer and replace it with another type before that gets back up to temperature. By the way, this is the ending script, which shuts down the printer after the nozzle reaches a temperature of 50 degrees. And you can see here, I'm using a G10 command. Now, typically we're used to seeing an M109 command for set extruder temperature and weight. But with the M109 command, it's looking for a rising temperature. So in other words, if it's, 45 degrees, 46, 47, it's not going to do anything. It gets to 50, 51, that's when it turns off. But with the G10 command, which is just sort of a much more primary command, it will reach that temperature either ascending or descending. And in this case, we're descending because we're cooling the nozzle down. So this is the command that works, whereas the M109 would not work. This part here is an aluminum casting that came off of a rear view mirror from my motorhome build. And I have a whole other channel which, I talk about that kind of stuff. So yeah, that was a scrap piece. Again, this is not a tutorial video, so it was a perfect piece of aluminum for this job. I didn't need to fabricate anything up. I just had to put 2 screws down here to attach it to the frame. And also, I never showed you guys the close-up of this hole that I drilled to pass the wires here to the hot end through. So yeah. So that is the state of this very functional printer as it sits right here today, making great ABS prints. You saw this test print here. What you didn't see, and I actually showed it in 2 videos ago, the video about making the filament spool holders, I printed for probably 4 to 6 hours on each of the filament types, PLA, PETG, and ABS. So this has already got plenty of hours pumping out those 3 materials, but I still could use some part cooling on this. So I need to add part cooling. And the big thing, this will be really tricky, and I've got a great idea for the mesh bed leveling sensor, that clicky switch that has to touch the bed. Fantastic, fun implementation of that. I think it's going to be pretty unique. Nobody else out there has done it quite like what I've got in mind. So stay tuned to that. Pretty exciting stuff coming. And of course, the big obvious thing, we're going to be putting chamber around this printer. So this is a 4x8 sheet of expanded polystyrene, styrofoam with this foil backing. Should help with fireproofness of the chamber, as well as, is that a word, fireproofness? Fireproofing of the chamber, as well as a nice reflective thing to keep the, what is it? That's not conductive heat, that would be the radiant heat. Keep the radiant heat inside of the chamber. Don't know how much radiant heat you really need to keep. I think it's more about the air temperature, so it's all about the conductive heat through the air. So anyway, yeah, we're going to get this thing into an enclosure as well as adding those other peripherals. And in the next video, I should be fully finished with this build. And I can't imagine a better hobby level, or call it consumer level, 3D printer out there. I really can't. So if you guys can build better, and I'm sure that there's a lot of guys out there who could do better than this, please leave me a message. I would love to feature your guys' builds on this channel, because I don't want to be the only one out there making these funky DIY 3D printers like this. Now I want to talk about the combination of the Slice Engineering, the Copperhead heatsink, or I'm not, sorry, heatsink, but the hot block and the throat in combination with that BQ H2 extruder. So the BQ H2 extruder, pretty neat design, very closely derivative from the Slice, no, what is it? The E3D Hemera. Now, the metallurgy and all the attention to detail on the Hemera, vastly superior to the BQ extruder. Also a whole lot more expensive, also a whole lot more not available. Now I paid my own money for this Copperhead. Here's my invoice, and I'm saying unbiased right here, that is an awesome heat break and hot block. Not as good though, not as good as the Mosquito. I've tested the Mosquito. I also paid for the Mosquito, so tested that before here on this channel. And it's just fantastic. As far as like real engineering work goes, nobody out there doing just as stellar a job at the engineering of the physical components that go onto a 3D printer as Slice is. And that includes E3D. So just so awesome. And it's such a, well, I hope that they can make it work with their business, and they can continue to grow, even though they are under a lot of pressure from the copycat cloners from China, who don't have to pay for all of the research and development. All of that, there's a massive amount of time that it takes to get to a product that works this well. It looks so simple. It's deceptively simple. Getting it boiled down and simplified takes a lot of effort. Anyway, I'm really excited for this build to be completed, and maybe I'll even order some of that really expensive PEEK material and print some crazy high temperature something or other just for the fun of it. I don't have any use for PEEK at the moment, but I use a lot of polycarbonate. I really do love that stuff, and that's the primary motivation for me building this printer, is I want to be able to print the strongest possible prints. So polycarbonate, reasonably priced, and once I can get over the shrinkage problems, because I'll have a chamber, I will be quite happy. Okay, my sincere thanks and gratitude to these Patreon supporters. Without these guys, I would not be making videos. You guys are the reason for all of this. So I don't know what it is, but my AdSense revenue has just been falling like crazy these days. Maybe it's the fallout from the state of the world or whatever it is. It's funny, when I do more review videos, I think those Chinese companies actually pay to advertise on my channel. So when I do fewer review videos, then I get less money from AdSense. So when I'm doing the videos that I find interesting, and I hope all of you guys find interesting as well, build videos like this. And with that, we'll end the video. Thanks for watching. See you in the next one.